Throughout November 2025, post-perihelion images of 3I Atlas revealed an unusual feature. The object displayed a teardrop shape with an extension stretching about 1 arc-minute toward the Sun. This is opposite to what we typically see with comets, which develop tails pointing away from the Sun. During the same period, NASA's JPL Horizons tracking system reported something equally intriguing. The object is experiencing non-gravitational acceleration. The magnitude of this acceleration is small, roughly 0.0002 times the gravitational pull from the Sun. But what makes this significant is how it behaves. The non-gravitational acceleration scales inversely with the square of the distance between 3I Atlas and the Sun. This is exactly the same pattern as solar gravity itself. This means the ratio between the two forces remains constant throughout the object's orbit. The dominant component of this acceleration pushes 3I Atlas away from the Sun in the radial direction. One way to think about this is to imagine 3I Atlas responding to a Sun that has slightly less mass, reduced by that fraction of 0.0002. Harvard astrophysicist Avi Loeb has proposed an explanation for the Sunward extension. If 3I Atlas is surrounded by a swarm of objects that do not share its non-gravitational acceleration, these objects would naturally position themselves closer to the Sun relative to 3I Atlas. This is because 3I Atlas is being pushed away from the Sun, while the surrounding objects are not. Here's how the physics works. In trajectories shaped by solar gravity, energy per unit mass remains constant. However, 3I Atlas has slightly less gravitational binding energy due to its reduced effective solar mass. If the surrounding object started at the same position and velocity as 3I Atlas, they would have surplus gravitational binding energy. To maintain the same total energy and track alongside 3I Atlas, they would need to be displaced closer to the Sun by that same fraction of 0.0002. At 3I Atlas's current distance of 270 million kilometers from the Sun, this displacement calculates to about 54,000 kilometers closer to the Sun. From our viewing angle on Earth, this translates to an angular separation of 0.7 arc-minutes. This matches closely with the observed sunward elongation of the teardrop glow around 3I Atlas. As long as these objects don't experience their own non-gravitational acceleration from mass loss due to solar heating, they should maintain what astronomers call an anti-tail geometry. This means they would always point toward the Sun relative to 3I Atlas, converging at the object's closest approach to the Sun, or perihelion. Now here's where it gets interesting. A large swarm of small objects would have a much larger total surface area than 3I Atlas alone, even if their combined mass is just a tiny fraction of the main object's mass. Consider this example. 1 trillion objects, that's 10 to the 12th power, carrying just 0.001 of 3I Atlas's mass, would have a total surface area 100 times larger than 3I Atlas itself. This swarm would reflect 99% of the sunlight in the glow around 3I Atlas. This is consistent with observations from the Hubble Space Telescope image taken on July 21, 2025. The configuration explains another puzzle. The teardrop shape toward the Sun appeared with similar angular extent both as 3I Atlas approached the Sun and now as it moves away. This consistency makes sense if the spatial extent of the swarm is proportional to 3I Atlas's distance from the Sun, always pointing sunward. 3I Atlas, discovered by the Asteroid Terrestrial-impact Last Alert System on July 1, 2025, has displayed 13 anomalous features cataloged by Avi Loeb, founder of the Galileo project. These include unusual brightness patterns, trajectory deviations, and now this sunward anti-tail. Loeb has also documented what he describes as a heartbeat-like pulse in 3I Atlas's brightness. The light varies in a regular cycle, repeating every 16.16 hours. Rather than coming from rotation of the nucleus, most of the light appears to originate from the coma, the cloud of gas and dust surrounding the object. This suggests periodic puffs of material being released. Speculation has ranged from natural explanations to more exotic possibilities. While the object doesn't travel at light speed or create warp signatures like science fiction spacecraft, its unusual behavior continues to generate scientific interest and debate. NASA's official position remains that 3I Atlas is a comet. The space agency reiterated this stance during a photo release 2 weeks ago. The key question now is this: if the anti-tail is indeed a swarm of non-evaporating objects, what is their nature? Are they rocky fragments shed from the main body, ice particles, or something else entirely? All eyes remain on 3I Atlas as it approaches Earth. On December 19th, it will make its closest pass at 1.7 astronomical units. That's the closest approach of an interstellar object ever recorded. Multiple observatories are tracking the object, and more detailed observations should soon reveal whether the anti-tail hypothesis holds up. Whether this turns out to be an unusual but natural phenomenon, or something more extraordinary, 3I Atlas continues to push our understanding of interstellar objects and the physics governing them. As always, the data will guide us to the answer.